Well, hello Internet, and welcome to my review of what I think is the best STEM toy for kids. And it is the mBot Neo. It has line following capabilities, collision, gyroscopes, color detection, accelerometers, sound detection, recording, text-to-speech. It can translate into multiple different languages. It has machine learning capabilities, wireless communication. It has an onboard programmable CyberPi computer. It does so much. And now I'm going to have my daughter show you everything with an unboxing. All right, so this is going to be a long video because I'm going to show you 7 projects you can create with the mBot Neo. You can see right here is a shield. This is what you're going to be able to plug all your components into, and has a rechargeable battery, and that is it. Also, we have an aluminum frame or chassis, and it is really sturdy and pretty cool looking. This is the CyberPi computer. It has numerous different input options, so you're going to be able to trigger different actions you want your mBot to take depending upon the input received here, and it also has an LCD screen that you can print out to. You can also under here find all sorts of manuals. Now, I did an assembly video for the regular mBot. Not doing that this time because it's so extremely simple. I'm going to focus on showing you how to program the mBot Neo with tons of projects. And in the description, you're going to be able to find ways you can jump to different parts of the video if you want to do that. So here is the assembly instructions, way easier than the mBot even, which was pretty easy, and you can find that all in the manual. So I know you're not going to have any problem with that. This right here is the line following map that we're going to be able to have our mBot do different actions depending upon colors it senses. You can see also, of course, we get our tires that are for here for our mBot. Also comes with a screwdriver. All the tools you need are included. You're going to have nuts and bolts, everything you need. Here is an ultrasonic sensor that also has eyes that light up. Of course, all of the cables that you need, including the USB cable, are also included. You're also going to have a quad RGB sensor, which is going to be used for line following, encoder motors. So if you want your mBot to go 5 centimeters, it's going to go precisely 5 centimeters. And here is the app you can use with it as well. And this app is free. You download it on Android or Apple. Just go and select the mBot 2, and you're going to be able to just click on this and drive it around. It's going to do all kinds of things. You can easily connect just by putting your device right next to your mBot. Boom, connected. That easy. And it has all kinds of built-in ways to drive the mBot around and have it dance and such. Pretty cool little things, and a nice way to get your kids to start interacting with it. It also has the ability to just draw with your finger, and then the mBot is just going to go and draw or move around wherever you drew. And it also has a built-in organ so it can play music as well. All right, so I'm going to show you how to create 7 complete projects, write all the code, and show you demos of everything running. And now I'm going to show you how to install the software on Windows as well as on Macintosh. So if you're on Windows and on Mac, you just go to makeblock.com/software like this. You're going to scroll down to the bottom of the screen and you're going to see mBlock 5, and you just want to click on download. And then you're going to see you can download for Windows, Mac, as well as on Linux. So in this situation, we will download for Windows. Click on download, and of course it's going to download everything for you. And once it goes and completes, just double click to execute it, and it's going to install everything you need. You may get a message like this. If you do, just click on install. And then you're going to want to put a check mark right here where it says run mlink 2 and click on finish. And there you go. Everything's ready to go. And if you want to start the program, just click on create now. And it's going to ask you in what browser you want to run the software. So you pick whatever browser you'd like and click on OK. And this is what you should see on your screen. Something like this anyway. You're not going to see this part here, but you're going to see everything else. And to create a new project, you just go up here, click on File and New. And there you go. And now you're ready to go. Now, if you are on Macintosh, you're going to go to makeblock.com/software. Exactly the same. Go down to where it says mBlock 5, click on download. You're going to see a screen like this. You're on Mac, so click on download next to Mac. And of course, you're going to, after it goes and downloads, click on open. And then you're going to go and drag the mlink 2 into your applications folder from your downloads folder. And if you don't know where applications is, just click on the little magnifying glass up here, type in applications, and you're set. then you double click on it. It's just that simple. And then, just like before, you're going to go mBlock, block-based editor, click on Create Now. And it's going to open up, and it's going to look something like this also. Now, whenever you go to open up your device so that you can interact with your mBot Neo, you may get a message like this. And this just means that you need to have mLink opened up. And that's true on Windows as well as on Mac. And now we're ready to start programming. Now, the very first thing you'll want to do is you're going to want to connect your mBot Neo, and also you are going to want to update the firmware. So to do that, you're going to come over here where it says Add, click on Add, and then you're going to go to mBot Neo and make sure that you have that selected. You can put a little star here to favorite it, and then you're going to click on OK. And it's going to connect to this after you come down here and click on Connect, right like that. And it's going to automatically detect where it is, unless you have a whole bunch of weird things connected to your computer. More than likely, it's going to be the first thing that pops up. Click on Connect, and you are ready to start programming, pretty much. We're also going, just one thing to note, it's listed as CyberPi, not mBot Neo whenever you connect, because CyberPi is going to do all the programming and all the stuff for your mBot Neo. But you're probably going to want to come in and update your firmware. To do that, you go down to Settings, click on that, and then you can click on Firmware Update. Host name is going to be the name of your device, and right here you can click on and set up your Wi-Fi. But we're going to get into that later because we're going to be able to get our mBot to go and connect through the Wi-Fi to the internet. It's crazy. All right, so if you want to update your firmware, just click on Firmware Update like that and select the device and the firmware and click on Updates, and it's going to update for you. I'm not going to do that because I just updated my firmware. All right, so to close this after you got it open, just click there. All right, so I'm going to give you a rough overview of what all these components do because there's so many of them. So in the audio components, you have the ability to play different sounds, and they are going to simulate different emotions. So happy and sad and curious and such. Very cute. And you can also see the similar things right here. You're also going to be able to record sound, and you're going to be able to stop recording and play recording. You're going to be able to play notes. You're going to be able to play different musical instruments that are going to go at a specific beat. So all kinds of things to play around with there. You can control your volume as well, and you can also play different tones and such. LED. On the CyberPi, there is a screen. Now, when it says display like this, on the back of the CyberPi, there are 5 LEDs. You can change the color to them. And then there's a whole bunch of different settings that you can also play around with animation-wise with those LEDs on the CyberPi. And you're going to be able to also change different colors depending upon different time frames. You're going to be able to set red, green, and blue, and so forth and so on. So that's what LED does. Display. Again, on the CyberPi, there's a display in the middle of it. You're going to be able to print words on it. You're going to be able to get data, put that data on the screen. You're going to be able to create line charts. You're going to be able to create bar charts. You're going to be able to create tables of data. Brush color is going to be the color of your graphs and so forth and so on. And also clear the screen. Motion sensing. What else are we going to be able to do here? Well, we're going to be able to sense the angle. The mBot, or the CyberPi, has an accelerometer inside of it, gyroscopes, and you're going to be able to sense the different angles, the accelerations, the yaw, the pitch, and the roll. So all the different angles and rotations, you're going to be able to control all that. Sensing. There are joysticks as well as buttons, and you're going to be able to perform different actions depending upon those different actions that you take with the CyberPi that are going to affect the mBot. You're also going to be able to sense loudness, ambient lights. You're going to have timers, battery levels, all that stuff. We'll be getting into it later. You can also do local area network messaging. Sometimes you'll be doing this between, if you have multiple mBots and mBot Neos, you'll be able to do that as well. It also has all sorts of AI capabilities, which we'll get into also. It can go and understand speech, so it does speech to text and text to speech and backwards and forwards, as well as translation between different languages. Internet of Things. This is going to allow you to connect to the cloud, and you're going to be able to get all sorts of information in regards to location data, air quality, temperatures, and all of that. Events. This is going to give you the ability to run different code depending upon whether keys on your keyboard on your computer are pressed or keys on the mBot are pressed. So whenever this happens, then we'll make this other stuff happen. We are also going to be able to loop through and continuously perform actions over and over again. If this feels a little bit overwhelming, don't worry about it. This is just an overview. It will all make sense whenever I work you through real projects. Operators allow you to do some math, and they also random numbers. They allow you to perform more complicated conditional statements. Variables. Sometimes you're going to want to store data inside of a variable, which is just a name assigned to some type of data. You also can store lists, and you can create your own custom functions, just like we have here. We're going to get into that. Ultrasonic sensor. Those are the two eyeballs on the front of your mBot Neo, and they're going to allow you to judge the distance that you are from different objects, as well as being able to set the brightness and change the colors on the eyeballs of this sensor. So you can add all sorts of personality there. Now, if you want to move your mBot Neo, you're going to come down here and you're going to click on chassis. This is where all of the motor work is going to be. You can tell your mBot to move, and because we're using encoder motors, which are ridiculously precise, we're going to be able to say how many centimeters we want to move. Or if you prefer to use inches, use inches. And you can go and rotate it and move specific distances or at specific RPMs, just everything. Okay, extension ports. You're going to be able to add servo motors. You're going to be able to add arms and all sorts of different attachments and move them at specific angles and so forth and so on. Connect to LED strips and all sorts of other stuff. Then you have the quad RGB sensor. What this is on the bottom of your mBot Neo, you are going to have sensors that are going to be able to track lines depending upon different colors, and if the colors change, those sensors are going to know the color change. It can detect different colors and perform different actions depending upon color changes. And that's not it. You also can come down here where extensions are, click on that, and you're going to have all sorts of other different components you can add. Cameras and other different display information, sliders, all sorts of stuff. The whole way up, I mean, there's sensors, pretty much any sensor you could want to attach to it, you can attach to it. And we're going to be even getting into machine learning type tools. So if we click on sprite extensions, teachable machine, you're going to be able to teach using your mBot how to recognize different objects. So this thing also does machine learning. I mean, it's never ending. Okay, so that's an overview of how to connect, how to update firmware, and all of that stuff. And let's just jump into creating some ever increasingly complex projects to get you very well acquainted with how the mBot Neo works. Now, one thing to be aware of is sometimes you are going to have to be in upload mode. Now, you're going to use that whenever you want to go write code and upload it directly to your mBot Neo. Okay? Pretty simple. Live mode is whenever you want to have your mBot Neo connected to your computer and interact with it directly there. So it's very important to be in the right mode depending upon what different things you are doing. My mBot is currently connected to my computer as we speak. Now, for our first project, what I want to do is my daughter set up a whole bunch of Legos. And what we did in a maze formation, you can jump ahead in the video if you would like. And what we did was we measured out the distances as well as the angles the mBot Neo would need to traverse to be able to go forward through the maze, out of the maze, turn around, go back into the maze, pull back in, and park. All right? Kind of complicated. So what are we going to do here? Now, in your situation, your distances are going to be different, so you just get a ruler out and measure everything. All right, but I'm going to walk you through the whole entire process, and then after this, you're going to see the demo, or if you'd like to jump ahead, see the demo, jump back, whatever. All right, so the very first thing we're going to do is we want our mBot Neo to start doing things whenever a button is pressed. Anytime you hear something like that, an event occurs, like a button press, we want to do something. events. That's where we are. And what do we want to do? Well, we want to say when button A is pressed, we want to come out here and we want to have our mBot go and traverse through a maze. So here is the event, and now we want to move it. How do we move our mBot? We are going to move it by going to mBot to chassis. This part right here. Okay, so that is moving the mBot. So I'm going to click on that. And what I want it to do is I want it to move. It has encoder motors. That means it can move very, very precise distances. Very cool stuff. All right, I want it to move forward through my maze, and I want it specifically to move 30 centimeters. Now, there's going to be some slippage. You have to understand, in the world, we have friction. We have, all sorts of other things that play in. So this is going to be something you have to work through depending upon what type of surface you are working with and how that surface may change how friction affects the wheels on your mBot Neo. All right? But we measured it. 30 centimeters seemed about right. Then in our maze, we need to turn left. So I wanted to turn left 90 degrees. Then I need to move forward to get through my maze, and that is going to be 30 centimeters. Now, something you can do is you can click on this, and you can say duplicate. Grab it, drop it inside of there. So what are we going to do after we turn left? Well, I measured it, and our maze required 33 centimeters of distance, and then we're going to turn right 90 degrees, so we're facing the original direction we were in previously. And then I want to move forward 35 centimeters until done. See, very, very precise. This is 35 centimeters until done. And then what I want to do is, let's say I want my ultrasonic eyeballs, my sensors, to make a weird sort of dizzy look. Well, if I want to go and change that, I just go ultrasonic sensor, right like this. And we want to come right here to this part and drag and drop that in. So this is the code so far. And let's say that I want it to simulate a motion of dizziness, okay? So that's going to make the eyeballs light up. Then what do I want to do? Well, I want to go and have it go back home to where it began. So to do that, I need to start moving it again. So I'm going to come down here, mBot to chassis. There we are. And I want to turn left 180 degrees. I need it to go back to where it was. So turn left, boom, drop that in there, 180 degrees. So there it is. So now it's facing backwards to go back into the maze. I want it to move forward a very specific amount. That is going to be 30 centimeters. And then I want it to turn left 90 degrees. See, we're going backwards, turn left 90 degrees. And then after that, move forward. In this situation was 34 centimeters. Remember, friction, it causes some changes. And so we'll go forward, and that's going to be 34 centimeters until done. And then I am going to go and have it go left because I want it to back in so it's facing exactly the same way that it was previously. So I'm going to go left. And in this situation, because of friction and such, this ends up being 95 degrees. Again, something you can play with. And then we want to move backwards 30 centimeters so that we are in our original starting position. So we're going to say backwards, and this is going to be 30 centimeters. And then I can go and display another emotion, and let's come out of here, and we'll go to ultrasonic sensor 2, and we'll drag this right here, and we can say that our mBot is back home again, and it's very happy. And you can pause your screen right there if you want to get a better look at the code. And now what you're going to need to do is to go into upload mode, right like that. See, I clicked on upload, and you are going to upload your project to your mBot. And it's going to upload, and it's on there, and your mBot is ready to go and drive through your maze, all right? And now I'm going to show you that demo. Okay, so here's our robot going through the maze very, very precisely. And you can see this is just like programming a robot like Amazon does. And it's going to get out to the end of it and turn around, and it's going to pull back in, and it's going to back into position. So really cool, awesome education. All right, so now let's go and create another project. This time I'm going to show you how a bunch of sensors work and a whole ton of different things all at one time. Okay, of course you can come up here and save the name of your project, but you need to be logged in. So you're going to need to click up here and sign in. It's all free, but you need to click on that to be able to save to the cloud. And you can also come up here and go File and Save to your computer, always safe. And then open from your computer and so forth and so on. So let's say we want to do a whole bunch of things depending upon different interactions we have. Well, this is going to be live mode. So this is going to be your mBot Neo plugged into your computer, and you're going to be interacting with it. So we want to click on live. And the very first thing we want to do is, let's say we want to have things happen whenever the space bar is clicked on inside or on your keyboard. You can also do space, up arrow, down arrow, left arrow, any key, and all of these other different characters. See? So basically a lot of stuff that's on your keyboard. Okay, so let's drag this up here and let's get in here so we can actually see it. Maybe I want to come in here and zoom in. So I zoom in just by that. And then also you can come down here and do redo and undo. All right, and there we are. So here we go. We got our space key on our keyboard is clicked on. Well, what I'd like to do is set it up so that the mBot is going to, if something is less than 10 centimeters away, it's just going to turn 90 degrees. How can I do that? Well, I want this to be something that's continuous after the space bar is clicked on. So in that situation, we're going to go to Control, and we want this to be a forever action after the space bar. So it's going to continually do this over and over again. Then what I want to do is I want to go and have it be based off of a condition. So we want to do something, and if the mBot is not less than 10 centimeters away from something, we just want to turn the motors off. So in that situation, we're going to say if something it's less than 10 centimeters away, do something. Otherwise, just turn the motors off. So what we want to do is we want to go and check that, and we're going to need an operator for this. And we specifically are going to need this operator, less than. Now remember, I said less than 10 centimeters. So let's put that like that. We're going to then need to go and use our ultrasonic sensors to be able to come in and check distance. So ultrasonic sensor to that guy right there. And we're going to look for distance to object, distance to an object. And whenever it's rounded off, that means that it's going to fit in a rounded out block, a rounded off block. See how it's rounded off? So there we go. And you can see here that we're checking for distance less than 10 and centimeters, as it says right there. Now, if we are that close, what we want to do is have our mBot turn to the left. So we're going to click on chassis again. There's chassis. And we want it to turn to the left 90 degrees until done. There we are. And if it is not less than 10 centimeters away, we just want to turn the motors off and just have it sit there. And there we go. And what you can do on your computer is go and click on the space bar and see that happen. All right, so let's go and get some other functionality, and let's use the functionality that's provided by the CyberPi's controls. So again, we're going to come in and we're going to specifically go to sensing over here. This is going to be the CyberPi controls. And just like before, we're going to go to events, and we're going to use the CyberPi controls. So we're going to use the joystick this time. So let's drop the joystick and let's just leave it there. Let's say when the joystick is pushed forward, let's say we wanted to display a timer. All right. Well, let's go into sensing. There it is. And we want to go and first reset our timer. So there it is. And then forever, we want to display changes in the timer. So we'll go to Control, Forever, drop that right there. And we want to show a label on our display. Well, display is right here. And very often you're going to be using this. You can go and put in specific X, Y coordinates and so forth, but you don't have to go to that detail. Just put it in the center. So let's go and drag that, drop that right there. And in the center of the screen, I like to use medium pixels because I can't see very well. You can change the pixel size of the text that's in the center of the screen, or you can put it at the top or wherever you'd like. Center of the screen works pretty good. And what I specifically want to put inside of there is the timer data. So sensing again, And I am going to go timers. And it's going to automatically, whenever the joystick is pushed forward, going to show the changing timer values. And another thing you can do is you can come in here and right click on this and say add comment. It got crazy and went the whole way over there. Let's bring it over here so we can see it a little bit better. And we can shrink this down, move it around, and maybe we want to know what this code actually does. So we'll call this starts and stops timer, just to be simple. And there we go. So that's how you can add a comment to code to make it easier to understand. Let's do some more functionality. So again, we're going to go to events. And this time what we want to do is we want to go and create a graph of the decibel level. The CyberPi has microphones and also has speakers. So it's going to be able to sense the sound around. And what we want to do is we want to draw a line chart on the screen. So joystick, bring it over here. And we're going to say when the joystick is pushed to the left, what we want to do is first off, we want to clear the screen. So we'll go to display and go clear screen, drag that up there. We can change our color. So let's drag this here and maybe we want to make our color blue. So we can go and change these different colors. Let's change it to blue. There you go. Change the brightness, whatever you'd like. And now what we want to do is forever, it's going to go and get the decibel levels and create a line chart on your screen. So forever, how do we do that? Control, and we go forever. And don't worry if you don't remember this stuff. With time, you will remember it. Okay, then we want to display a line chart. And I'm just going to come in here and go line chart and add specific data, which is going to be loudness data. So I'm going to say line chart and add data. So drop that there. We're going to want to go and get the loudness. So we clicked on sensing, loudness, and it is going to display the bar chart with that different data inside of it. All right, let's keep adding some additional information. Let's say we would like to also come in here and go and display a table. So if somebody presses on the CyberPi's joystick down, like it's a button, so again, we're going to go to events and we are going to look for when joystick, like this, drag that over here, it is pressed. So we'll say middle pressed like this. Well, what we want to do is we want to display on the screen a table of data. Well, what do you think we're going to use? Display probably. First we want to clear the screen and then we want to go and display table data as it changes. And the data we're going to display is the ambient light intensity, the loudness, as well as the battery levels. So what are we going to need? Well, we are going to need to do this over and over again. Anytime you want data to constantly update, you're going to need a forever block. Now we need a table. So we're going to come in here to display and we are going to display everything. Let's go and drop this right here. You can see we can have 4 rows and we can have 3 columns. And what we want is we're going to go in 1-1. We're just going to type in light like this. And let's go and duplicate this so I don't have to hunt for it again. And then in this, we're actually going to put the ambient light intensity. We want it to be in a table to the right of the word light. And so we can come in here and go to sensing, ambient light intensity, drop it right there, and it automatically works. Let's go and duplicate it. Let's drop that right there. And we also said we wanted to do our battery information. So just come in here and we're going to, this is the first row. This is going to be row 2. This is going to be row 2. There's still going to be 1 and 2 there. And then this is going to be row 3. And you can go and get some additional data if you'd like to put it inside of there. But this all looks pretty good. And what do we want to display? Well, how loud are your surroundings as well as the current battery level for your mBot Neo. So that means I need to get rid of this. Goodbye and goodbye. And battery levels right here. So let's just drop that right there. And then the loudness. Drag that and put it right there. And there you go. Whenever you press the middle button on the joystick, it's going to display that nice table for you. Let's keep adding additional information. Let's say that we would like to just put the ambient light intensity just as a one-time thing in the center of the screen. So we can go, again, this is going to be an event, and let's go button A is pressed. That looks okay. And we just want to show a simple label. So we're going to go like this, and we're going to go and grab this, drop this inside of there, center of the screen. We don't want to have our blocks overlapping though. And then inside of this, we want the ambient light value to show in the center of the screen if A is pressed. All right, so where's that? That's sensing and ambient light intensity. So drop that right there. And let's say we would like to display the loudness amount. Let's just duplicate this, put this right here, and change this to B. And let's get rid of this. Whoops, let's grab it, get rid of that. And let's say that we want the loudness if B is pressed. Whoops, you know what? And I put it in X and Y. I don't want that. I'm going to get rid of it. I am a stickler for doing things in a very specific way. So I want to go like this, get this one, and put it in the center of the screen. There we go. And now I'm going to also duplicate that, put this right here, and then I am going to do this the proper way, sensing, and we are going to do ambient light intensity, and that will display, and then loudness will display if B is pressed. And there is that finished code as well. What else would I like? Well, maybe we would like to have the ability to clear the screen on a whim. Well, let's go and let's try our joystick. So you can see there's numerous different ways to add functionality. So if the joystick is ever pulled down, what we want to do is stop everything and clear the screen. So we'll say display, clear the screen, drop that right there. And then we want to do a stop all, which is under control. So just grab stop all, drop that right there, and there you go. So if the joystick's ever pulled back, clears the screen, stops everything. All right, anything else? Yeah, why don't we go and display some information in regards to the tilt of the mBot. So again, we're going to go to events, this guy here, and joystick. If the joystick is pulled, we haven't used pulled to the right yet, so let's have it pulled to the right. In that situation, we're going to say we want to duplicate this clear screen thing. And let's go get this, drop that over there. We don't need this stop all. And what we want to do is go and display rotation information. So motion sensing is where that is. So we are going to go and reset our rotation angle whenever this is set, because we want to get changing rotation after that. And we want to constantly update that information. So we're going to say control and forever. Remember, if you ever want something to continue happening over and over again, get a forever block. And then we want to go and let's say we want to show this information on our display. So I'm going to go like this and drop that right there. And what we want to put is the tilted forward angle, which I think is the yaw, something like that. All right, so let's do that. And let's go and grab it. No, it's actually the pitch. I just thought of it. Okay, yaw is rotating on the z-axis, and roll is rotating on the x-axis. Okay, so let's go. Motion sensing, and we are specifically tilted forward angle. Let's grab that, drop it there. Now that's being displayed as well. And just so I can zoom in so you can see everything here on the screen. And let's do one more. Let's play around with the LEDs on the back of the CyberPi. So to do this, I am going to go and I'll do events, and I can go and I think I used every one of them, up, down, left, right. Why don't we just come in here and let's do this. We'll have this happen whenever you press, let's say, A on your key. Okay, in this situation, we're going to change the LEDs. So I'm going to come in here to LEDs. And let's say I want to change my brightness. I'm going to change my brightness to 100%. And then let's say I want to play a animation. So drop that right there. And I want to do a rainbow animation. Then I can go and change my display color to whatever I would like. And then let's say that I would like to wait for a certain amount of time. So I'm going to say that I want to wait 1 second. So there's the wait 1 second, under control. Wait 1 second, drop that there. And then I want to go and change all of the LEDs to a simple color. So let's go like this. And we can say something like LED all displays red for 1 second. How about that? Grab that. We can change them individually also with this guy. And there you go. So there is a rough overview of how to use multiple different components on the mBot Neo as interacting with the CyberPi. And now I will show you a demo. All right, so this is kind of a silly example, but you can see here I'm getting the ambient light intensity, and that is coming from the sensors on the bottom, by the way. That is the loudness, and here I'm yelling, so that's the reason why the loudness went up. And here I started a timer, and then I'm going to push down to clear the display and stop everything. And this is also going to be a graph of me yelling and such. And I cut that out of the video so you didn't have to listen to it. And so I'm just playing around with other different components, such as being able to monitor the pitch of the mBot and show you how that is displayed. I'm going to show you a more complex one later on. And then also I'm going to show you how to display a table of information. So there you go. There is the demo. All right, so for the next project, what I want to do is show you how to record sounds, play sounds, and then test your recording, and then have your mBot play different sounds if they detect that they are close to an object. All right, so very first thing, we're going to have an event, and that event is going to be that they are going to, on the CyberPi, go and interact with it in some way. So, joystick. If the joystick is pushed forward, what we want to do is forever do something. So that's control. We grab a forever block, drag it, and drop it right there. Then we're going to perform different actions depending upon different other buttons being pressed. So it's sort of like setting your mBot Neo into a specific mode that you will then be able to interact with by pressing other different parts, whatever, buttons and such, on your CyberPi. So we want to do that. So we're going to say if, like this, then. And what we want to do is if they go and press the A button, and this is under sensing. So we're going to say if they press the A button on the CyberPi, what I want to do is I want to display a message on the screen with a label. And it's going to say record now, right like that in the center. And we can change our pixel sizes, remember? And then what it's going to do is start recording. That is under audio up here. So I'm going to say start recording. And it's going to save what you're doing. And then it's going to stop recording at a certain point. So let's just go duplicate this, drag it, drop it right there. And we're going to say if B is pressed, well, we're going to stop the recording. So we'll call this record stop. And let's get rid of that. And let's go stop recording like that. All right, then maybe you want to test your recording to make sure that it recorded. So let's go and duplicate again and drop that right there. And we're going to say if, I don't want this one though. I want to get rid of this. I want the other one that's going to sense if the joystick is pulled down. So joystick and drag that right there. And let's change this to pulled down. And in this situation, it's going to play the recording that you have. So let's just get rid of both of those. And audio. And let's say play recording until done. Okay, there you go. So now you can record, store sounds, play them back, and so forth. But what we want to do now is we want to tell our mBot, hey mBot, if the middle button is pressed, so again, we are going to go to events, and we are going to go to joystick and drop that right there. And we're going to say if the middle button is pressed, well, forever, we want you to run around, and if you get too close to an obstacle, I want you to play this sound you recorded up here. All right, so forever, what are we doing? Control and forever block. There we are. And inside of here, we're going to perform different conditions depending upon if we're almost going to hit something. So in this situation, we're going to have two different things that we're going to do. So I'm going to use an if, then, or else block. And inside of it, again, it's going to be if the ultrasonic sensor senses that it's about ready to hit something. So in that situation, you're going to come down to ultrasonic sensor there, and you're going to say if, well, actually, nope, first off, made an error. Go to operators, and we're going to say less than 50. Let's change this to 10 or something. And then we're going to go ultrasonic sensor, and we're going to say, hey, ultrasonic sensor, distance to the object. I want to know that. So grab it, drop it right there, and you can see that if it senses it's 10 centimeters away from hitting something, well, in that situation, I want to display some information. So I'm going to grab this label, drop that right there, and let's do medium again, and we will say obstacle will be displayed on the CyberPi. And in that situation, I want it to turn to the left. So I'm going to go mBot chassis like that, turn to the left and 90 degrees. So there that is. Then I want to play this recording that I made up here. So I'm going to go to audio, and I'm going to say that I want to play recording until done. And there it is. So you could like scream or something, you know, or make some type of noise like that. And it's going to play that every single time it almost hits something. And then we can go display, and let's go grab this, drop that inside of there. And on the display, we can say forward instead of obstacle. And in that situation, we'll just move forward and at a specific speed. So again, chassis like that, and forward at, and drop that right there. And 50 RPMs per second, or per minute, sounds pretty good. And there we are. So now I can go and demo that for you. Okay, so my daughter is recording her voice, stopping the recording, playing it back to test it, and now it will run. All right, so now what I'm going to do is I'm going to show you how to take your mBot and have it follow lines. I'm going to show you how to create your own custom functions. And I'm also going to, whenever it sees different colors, it senses different colors, it's going to perform different actions. This is going to be an upload. So I click on upload over here for mode. And what do I want to do? Well, I want to have my mBot do two different things at the same time. And it can do that. What I want it to do is I want it to be able to follow a line, continue following lines, stay on the line, and there's a big chart with lines on it that's included with this. And if it sees a specific color, then it's going to do something else. But first, I need to go and have it just follow lines. Well, in that situation, I'm going to use a mBlock. I'm going to create my own block. So I'm going to click on mBlock, and you go and you give it a name. So I'm going to use the one that makeblock uses. So I will go simple line follow. There it is. That's the name of it. Now you're going to be able to go and pass in different data to functions and so forth. I'm not going to do that. This is just simply going to do something simple. So you can see it went and automatically created my custom function right here. So what I want this guy to do is I want it to go and use the sensors on the bottom of the mBot, and you can see those. They are the, oops, let's zoom out here, quad RGB sensors. All right. Now the way these work is we're going to be using quad RGB sensor 1, and we're using L1 and R1. Now if you look at that sensor, it's right underneath the obstacle detection device. If you look at the top, it'll actually say R2, R1, L1, and L2 on the sensor. What it's going to do is it's trying to follow a line. And the way it's going to work, let's go and grab this. So let's drag that out there, but we're also going to use another block. So we're going to use if then else blocks. So we're going to go to control, and we're going to say if, and drag this over here and attach it. And we'll grab this guy and drop it in there. So what we're saying here is if the mBot sensor is not seeing anything, it's going to give you 0, 0. if only the right sensor is sensing a line, it's going to give you a 0, 1. If only the left sensor is giving you a line, or seeing a line, it's going to give you 1, 0. And if we get 1, 1, that means we are on the line and we are doing everything the right way. So what we need to do is, if it goes and it only sees on the right sensor, well, we need to turn our mBot a little bit to the right so that the left sensor can see the line also. And if we only see it on the left, turn it a little bit to the left. And that's going to allow it to traverse a path that weaves and bobs all over the place. And if it sees both of them see it, well, then that's awesome. So let's just keep it that way. All right. So in this situation, the first one, we're going to say that both of the sensors can see the line. 1, 1, true. Okay. And if it can, we want it to move forward. How do we move forward? mBot 2 chassis like this. Move forward at, and we're going to use a specific speed, which is 50 rotations per minute. There it is. All right. Now we have situations in which the mBot is not seeing anything. So let's just come in here, duplicate, drop that there. Well, let's do if only the right sensor is seeing something. Well, in that situation, we want to go and have it turn to the right a little bit. And so turn to the right, I'm going to use, again, this guy here, drag it there, and we'll just say turn to the right, and let's do it a little bit slower so that you can tweak this and play with it. And it'll turn to the right a little bit, all right, until it gets 1, 1, and then it will stop doing that. So duplicate, it's very smart. In this situation, if we have a 1, 0, that means the left sensor can see it, but the right one can't. Well, in that situation, we'll turn to the left 20 RPM. Sounds good. And if we ever get into the horrible situation in which neither sensor sees anything, that is a 0, 0. They're both giving you a false. Well, we're going to go backwards until we see something. So we'll say move backwards, and let's do it really slow. Let's say 10 RPMs. Okay? So there is the final code for our custom program that follows lines. But now what we want to do, we want it to follow lines, but also we want it to sense colors. I mean, we want this thing to do everything. Okay, so we'll go events, and we'll say when the joystick, get this, drag it over here, when the joystick middle button is pressed, we want it to go and continue doing something until a B button is pressed, say. So anytime we want to do something until another event occurs, we use what is called a repeat until. So that situation, we're going to say control, and we are going to look for repeat until. There it is, repeat until. So grab repeat until, throw it up there, and let's say we want it to continue following lines until the B button is pressed. So again, we're going to come up here, sensing, and we're going to say button B pressed. So look for button, there's button A pressed, button B pressed. Drag that there, and we'll say button B pressed. There it is. All right, so what do we want to do? We want to continue following lines forever. Well, we want to follow lines using our awesome little block, custom block we use. We just slap it in there and it works, all right? Now, under the situations in which we see different colors, however, we want to do other stuff. I mean, we just never stop asking for it. All right, so we're going to go control, and this is just going to be a whole bunch of if then else, if then clauses. So drag that there. And we're going to say that if it detects the color blue, meaning the quad RGB sensor down here, if it detects the color blue, what we want it to do is we want it to go slow. Like you can imagine it's ice or something like that. So let's see here. RGB sensor, and I'm specifically looking for probe. So let's go probe detected, and I'm looking for a color. So let's go probe and this guy right here. So let's just grab it and let's drop it here. Sorry about moving around so much. I'm just trying to make sure you can see everything. Maybe it helps if I put it down here. Maybe that looks a little better. All right. So it's saying that if it sees, and I'm going to change this from R2 to R1, because R2, the two sensors are on the outside, and the one sensors are on the inside. So I want to use the middle one because that's what we're using to follow the line. And I'm going to say, hey, if that line happens to be blue, I want it to do some different things. So again, I'm going to go chassis, And what I specifically want it to do is I want it to move forward at a slower pace. So move forward at like this. And I'm going to change this to 10. Actually, why don't we do it for a specific space for a certain period of time. So we'll say move forward at, and we will change this to 10 RPMs for 1 second. All right. And we're going to be doing similar things here with the second one. So let's just go and duplicate that. All right, so if it sees red, so just come down here, and you can see it can see all those other different colors. Well, in that situation, I want it to go and turn around completely and go in an opposite direction. So to do that, I go turn, and let's put it right here. And if I wanted to go backwards, I go 180 degrees. And then I want it to move forward. Let's say I want it to move forward a specific distance. So I can do that. So move forward at a specific distance, and I'm going to say 4 centimeters. All right, that's how precise we can be. And that's good. So that's what will happen if it sees red. And then in this situation, let's say I want to do like a little dance if I see the color green. You can see there's all the different colors we can sense. We'll go green. And I'm going to say that I want it to turn to the left a little bit, turn to the right a little bit, wait, do a little dance. So I'm going to say turn left 90 degrees until done. So drag it like that. There we are. And then I say I want to wait for a little bit. So I'm going to go control and wait for 1 second. You can put like a half a second in there if you'd like. And then I'm going to have it turn to the right. So again, chassis, and turns to the right until done. And I'm going to change this to 180 like that. And then I'm going to have it wait for a little bit again. So go to control and wait and drag that there. And then I'm going to have it turn to the left. Anytime I'm doing anything with it, turning or driving, it's always chassis. I'm going to turn to the left 90 degrees until done. So do that. And then I'm going to move forward a certain number of centimeters also. So move forward and grab this here, drop it right there. And let's change this to 4 centimeters also. And then if our button B is pressed, in that situation, I want to stop everything. So stop the motors. So grab this, stop encoder motor all. All right. And there you go. There is all of the code. I'm doing my best to put it all on the screen so you can read it. And of course, we need to come in and upload it also. All right, so here it is. It's going along the lines, and it's going to hit the blue, and it's going to slow way down. It's going to hit the green, and it's going to do a little bit of a dance here. And the sensors on the bottom of the mBot Neo, of course, are handling it, and then it hits the red, and it goes backwards. So pretty cool stuff. All right, so let's make another project. This time we are going to have our mBot Neo go and constantly update the angle that it is currently in on both the X, Y, and Z axis, as well as show the constant changes in acceleration. So what are we going to do? Well, I'm going to come over and I am going to work with our joystick. So I'm going to go to Events and Joystick and drag that right there. And let's say that whenever the middle button is pressed, we want to go and use a forever block. So that is Control Forever. There we go. And I want to use a display of a table. So I'm going to come in here again. And what I want to do for tables is here again, rows and columns. So let's go and drag that into place. And I'm going to have the X angle displayed. And this is going to be row 1, column 1. And then I'm going to get another table input area. And this is going to be row 1 and column 2. And in this, or this says A angle, don't want to do that. I want this to be X angle. All right, let's just type in X angle like that. There we go. All right, so now I want to go and put in the different information in regards to sensing. So this is under motion sensing. And we're going to go to rotated angle around. So let's just drag that into place. And this is going to be on the X axis. And then we're going to do very similar things here. So let's just go drop that here. This is going to be the Y angle. And we need to change this to row 2 and column 1 and row 2. Of course, we're going to change this to Y angle. And let's duplicate this again, and let's change this to Z angle, and this is going to be changed to row 3 and row 3. Everything else there the same, except this has to be Z. And then let's go and duplicate one more time for acceleration. And I'll just abbreviate this to acceleration like that. And we'll have this be row 4, and this will be row 4. And we need to get rid of that. And we want to put in our acceleration information. And this is motion sensor. And let's do the X acceleration. All right, so what else do we want to do here? Well, we'd probably also like to reset our angle. So let's come in and events, and let's do button A pressed. And whenever button A is pressed, what we want to do is reset our rotated angles. So again, inside of here, and reset rotated angle around, and let's go and reset it to all axes. All right, and now I'm going to jump over and show you a demo. And there you can see in table format how as the mBot is being moved, it is constantly updating orientation data. Okay, so now what we're going to do is your mBot actually can understand speech and translate it into text, and then even translate that text in your provided language into another language. So it just never stops. Okay, so let's just come in here and let's go events. And let's say that if the joystick is pulled forward, so let's go get that in there and then maybe zoom in a little bit so you can see it a little bit better. Okay, so what I want to do here is I want to recognize the speech. This is under AI. And if you do not see all these, make sure you're in upload. Okay, we're in upload mode right now. And so you're going to need that. Okay, so what are we going to do? Well, actually something else. Whenever the CyberPi starts up, we're going to need to connect to Wi-Fi. So let's go into events again, and let's connect to our Wi-Fi. So we're going to say whenever the CyberPi starts up, right here at the very, very top, we'll drag that in. Well, let's put it down here. We need to do this first because we need to connect to the internet to be able, and your CyberPi and your mBot Neo has the ability to connect to the internet built right into it. So you're going to need to go, whenever CyberPi starts up, and we're going to need to connect to the internet. So go to AI, and you're going to go and connect to Wi-Fi. You're going to type in whatever your Wi-Fi name is, as well as the password for it. And it's also nice to be able to go and put some information on the screen. So let's say that we want it to display this rainbow pattern while it's trying to connect to Wi-Fi. And then we want to wait until, so we'll go down to control, right? Yes, wait until. And what we want to wait until is until we connect to Wi-Fi. So network connected, and like this. And then maybe we want to say duplicate, drop this here, get rid of this, and we will come in and change the colors for everything to green. So that means let's go, we got the Wi-Fi set and we're ready to rock and roll. All right, so you can enter your own Wi-Fi information in there, and I know you can do that. Okay, so what do we want to do now? Well, after we're connected to Wi-Fi and they push up on the joystick, we want them to be able to say some words and go and have the CyberPi go and get that information. So we're going to say recognize, and you can see all the languages it recognizes: Chinese, Cantonese, English, French, all that stuff. I'm going to use English because why not? You can put in how much you want to record here. I'm going to say 3 seconds worth of speech. And then I want to go and show what the person said or what you said. All right, so we're going to do this, drop this in there. Let's move this out of the way so we don't get that out in the way. All right, and what we want to do is we want to put the translated text onto the screen. So let's even take it up a notch. Maybe we want to show whatever they said in another language, let's say Spanish, and then that's in AI again. So we're going to say that we want it to translate this information. So we're going to say translate what they gave to us And let's just leave those in small pixels. Let's move the Wi-Fi over here just a little bit more. All right, so they're going to get that information and they want to translate it. Let's say we want to translate it into Spanish and display whatever they said in Spanish on here. All right, well, we do not, however, want to put hello in there. We want what the person said. So speech recognition results, drag that inside of there. And now it's going to display in Spanish whatever the person said. All right, so pretty neat stuff. But we can also go and say we want to speak it. So just drop that there. And again, speech recognition result. So not only is it going to go get the information that the person said, it's also going to translate it into Spanish, and then it's going to speak it into Spanish and display it and all that stuff. All right, awesome. Okay, so let's go and do some more events. Let's say when button A is pressed, it is just going to, again, recognize this information. Let's go into AI and drop this here and say it's English. So they're going to receive these English words. They are going to display a label. So this and this, drop that right there. We are going to go back into the AI part, speech recognition result. And here it's just going to display exactly what the person said. And also it is going to go and speak that information back to them. So isn't that awesome? Okay, we got more. Let's say that we also would like our mBot to receive information in regards to spoken words and then react to them. So we're going to be able to tell our mBot to go forward, go backwards, turn left, turn right, and so forth. Sounds really complicated, but it's not. Again, we're going to do events, and let's say this is just going to be button B. So we'll say button B. Whenever button B is pressed, well, then let's say we want to give it 3 commands. So we're going to go to Control, and we're going to say Repeat, and it's going to continue asking for commands 3 times. And what can we do? Well, let's say we want to display some info. Even better yet, let's have our mBot ask the user what the user wants it to do. So again, AI, speak, and drop that in here, and it's going to say, what should I do? Like that. Then after that, it's going, let's say we also want to display a label here. So go and display a label and say, what should I do? That'll display on our CyberPi screen. At this point, it's going to receive input from our user. So recognize, drop that there, and let's say 3 seconds is long enough. Of course, you can change that to whatever you'd like. It's going to be English. I am going to display on the screen the results. Now understand, you are going to be saying this to your mBot. It's going to be uploading it into the cloud, translating it, and then sending it back to you. So there's a couple seconds you have to wait for the information. So we'll come in here, we'll get this, and if you don't go and get the results, send them to the cloud, then come back, display the information, then do all this other stuff, that will cut down on your time. But I just want to show like everything. So what I want to do here is get the speech recognition results. Speech recognition results. So we're going to get what the user said, display it on the screen. And then at that point, we're going to perform different actions depending upon what they said. So that means we're going to have a bunch of if-then blocks. So control again, if-then, drop that right there. And what we're gonna work with a couple different words. So a couple different actions are going to be tied to a couple different words. So we're going to do operators like this, and we're going to say or, and then we are going to go and also check for words being equal to different things. So we'll say this is going to be equals. Whoops, I accidentally messed that up. Let's go get this, grab that out of there, drag it right there, put that back inside of there. Do the same here. All right, so if the speech recognition results, let's get this, speech recognition result, and you do not put quotes around these words you put inside of here. And then you might have to play around to see what, that's one of the reasons why I showed the label, because I want to see what the mBot thinks I said, and so that I can match that up with the actions down here. Now, if I say go forward, it goes and displays go forward with a period on the end of it. And we can go duplicate that, drag that right there. And also, I want to work with forward. So we can do forward or go forward. Now, if we tell the mBot to do that, well, what are we going to do? Well, we're going to need our chassis. Here this is. And we're going to say that we want our mBot to go forward 10 centimeters. So go forward 10 centimeters until done. So change this to 10 centimeters until done. And there we go. Now, of course, we can continue adding other different things to this. So we can go duplicate, drop that in right there. And let's say they say go backwards. So we'll say backward like that with the period inside of there. And then also, let's just say backward. And for some reason, oh no, in this situation, there is a period. All right, so good stuff. And then we'll just change this to go backward 10 centimeters. And of course, you can set this up so that it goes left and right and all of that as well. And I'll let you do that on your own because I am now going to show you the demo. All right, so you can see here how we connected to the Wi-Fi. It's green, and here my daughter says hello. It automatically translates that, and then it's also saying hello, and then she says hello again, and now it's going to translate into Spanish, which is really cool because she's learning Spanish. And here you can see it says, what should I do? And in this situation, I said go left or turn left, and it turned left. All right, so awesome stuff. And did I say that the mBot also has machine learning and the ability to tell the difference between different objects? Yes, it does. So let's go in. We're going to click on sprites to set this up. And then we're going to come down here where it says extension and click on that. Whenever we do, we're going to see this. And what we want to do is I know I have it already. Just click on add for teachable machine. It's right there on the extension part. And then you click on back after you get that installed. Then what you're going to be able to do is you're going to need a webcam. And what I did was I had two dolls. I had this Green Lantern doll, Ryan Reynolds, and another doll, Dumbo. And what I did was I just put my webcam over top of these different items and I clicked on learn. And it took about 20 samples, as you can see. So it took 20 photographs from different angles of the one doll and 20 pictures of the doll from this other doll. And then you take 20 pictures of your background. Again, hitting learn every single time to take all of those photos. And whenever you do that, whenever you jump back to your regular program, you're going to be able to hold your webcam and it's going to be able to automatically, whenever you put it on these different dolls, show you with 99% accuracy whether it's Dumbo or whether it is Ryan Reynolds or Green Lantern. And you can see here a live feed. If I put Ryan Reynolds inside of here, 99. And if I go and put Dumbo inside of here, Dumbo is now 99. And then if I take it away, you can see it lists his background. So pretty cool stuff. All right. And I don't know what happens if you put both of them in here at the same time. Well, it jumps back and forth. Ryan Reynolds is really shining over Dumbo. All right, so I hope you guys enjoyed this video. I very much enjoyed making it. And like always, please leave your questions and comments down below. Otherwise, till next time.